Welcome to Video 3 in Lesson 1, Sections 1 and 2. Here we're going to look at some more problems. Now in this first example, we're told that a rectangle has a perimeter of 22 centimeters, and the length is 2 more than twice the width. We have to determine the length and width of the rectangle. So to start, let's create a system of equations. And when we create systems of equations, we always identify some variables to use. So here we can have L and W, which should of course represent the length and width. So now to create our equations, I note that the rectangle has a perimeter of 22 centimeters. So we need to remember the formula for perimeter of a rectangle. And that is P equals twice the width plus twice the length. So that could be our first equation in the system. 2W plus 2L equals 22. Now for the second equation, we're told that the length is 2 more than twice the width. So if we double the width and then add 2, that would be the length, giving us this equation here. Now that we have our two equations, we can just graph each equation and then see where they intersect. So let's go ahead and do that. Now I'm going to let the length be the dependent variable, so I'll put that on the y-axis, and the width be the independent variable, so I'll put that on the x. So now to graph the first equation, you can use any of the previous methods that you've learned for graphing, but I'm going to go ahead and find the x and y intercepts, or in this case, the length and width intercepts. So let's start with the width intercept. So I'll let the length be 0 in the equation. So when I do that, I get 2w equals 22. So now I can divide both sides of the equation by 2, giving me a width of 11. So 11, 0 would be the point I plot on my grid. Now for the length intercept, we can let w equal 0, giving us 2l equals 22. Again, dividing both sides by 2, we get that the length is 11 as well. So that would be 0, 11. So let's plot these 2 points and then join them up. Now for the second equation, I notice that it's in the form y equals mx plus b. So I note that the slope is 2, or you can write that as 2 over 1 if you like, and the y-intercept is 2 as well. So putting a point right here on the y-axis, and then going up 2 over 1 a few times, I get my line. So now let's find the intersection point. That would be right here at 3, 8. Now 3 corresponds with the width and 8 corresponds with the length. So that means we can say that the width of the rectangle is 3 centimeters and the length is 8 centimeters. Now let's look at example 2. It says Sadie leaves St. Anthony and drives to Clarenville, while Jacques leaves Clarenville and travels to St. Anthony. The equations of the distance and time traveled by each car is given, where d is the distance from Clarenville and t is time in hours. When will the two cars pass each other? So we don't need to create our system of equations here. It's given to us in the question, so let's just go ahead and graph. So I have my time on the x-axis, that is the independent variable, and the distance is on the y-axis, the dependent variable. And when I graph the first equation, I notice that it's in the form y equals mx plus b. Now note that the slope is written last. So the slope is negative 100, or negative 100 over 1, whereas the y-intercept is 875. Now let's look at our scale. On the x-axis, every 2 blocks is 1, whereas on the y-axis, every block is worth 25. So that means 875 would be up here at the very top. Now for a slope of negative 100 over 1, I will go down 4 blocks and then over 2. Now doing that again a few more times, I get this, and now I'll join them up. Now for the second equation, the slope is 75, or 75 over 1, and the y-intercept is 0. So 0 would be down here in the corner. So having a rise of 75 and a run of 1 will give me this point here. And continuing that, I got my line. So now I note that they intersect right here at 5, 375. Now the question asks for us to determine when the two cars will pass each other. So I note that the 5 corresponds with the time, so that means we can say that the two cars will pass each other after 5 hours. Now in this last example, it says Rianne is considering two different cell phone plans. Now plan A charges a $35 setup fee plus $10 per gigabyte. Now plan B has a $55 setup fee plus $4 a gigabyte. So we have to create a system of equations and then graph to find the solution. So to create our system, let's first define some variables. We can let C equal the total cost and G be the amount of gigabytes used. Now for a system, we can have one equation being C equals 35 plus 10G for plan A, and then C equals 55 plus 4G for plan B. So now that we got our equations, let's go ahead and graph them on this grid. Now on the x-axis, I have the number of gigabytes used, where every 2 blocks represents 1 gigabyte. And on the y-axis, I have the cost of the plan, where every block is $5. So now for the first equation, I note that the slope is 10 and the y-intercept is 35. So let's put a dot here on the y-axis at 35, and for a slope of 10, I'm going to go up 2 blocks and then over 2 to the right, giving me this point here. So I can continue to do that a few more times and then connect the points. Now let me label that plan A. Now for the second equation, the slope is 4 and the y-intercept is 55. So 55 would be right here. Now having a slope of 4, or 4 over 1, is a little bit more difficult here, seeing as my scale is 5. So if I start at 55, if I go up 4, I would now be at 59. So I'm going to estimate my point to be around here. Going up another 4 means I'll be at 63. So here, and continuing that, I get this line. So this is plan B. Now part B of the question says, if Rianne normally uses around 2.5 gigabytes of data, which plan should they choose? So let's identify 2.5 gigabytes on the x-axis. So that would be right here. When I go straight up, I see that it touches plan A first, which corresponds to a value of $60. Now if I continue that line up a bit further until it touches plan B, I'll see that that corresponds to $65. So that means that plan A would indeed be cheaper. Now part C says, when will the two plans cost the same and what is the cost? Now to do this, we're going to have to estimate. So let's zoom in a little bit. So I see the point where they meet is somewhere between 3 and 3.5. Kind of in the middle there, so I'll say 3.25. Now on the y-axis, I see that it's in between 65 and 70, kind of in the middle, maybe a little bit above, so maybe 68. So I'm going to say that they intersect at 3.25 and 68. Now this is certainly going to happen sometimes when you're graphing. You're going to have to estimate, since your two lines may not always meet at a nice point. So this is why in upcoming sections we're going to look at a more algebraic approach to solving equations so we get more exact answers. But for now, we can say that around 3.25 gigabytes of data, both plans will cost around $68. So that is the last video in this section. You can now move on to the next activity in this lesson.